Hi, this is Irv Shapiro with the MakeWithTech channel. Now, I'm a very fortunate guy. For the last 3 years, I've had the opportunity to create hundreds of videos teaching people how to make things by using desktop technologies. And the majority of those videos are about 3D printing. So over that time, testing, 15, 16 different 3D printers, printing many reels of filament, I've learned a couple things. And I'm going to share with you today my top 10 tips, thoughts, ideas, things you should think about if you want to succeed with 3D printing. Now, this video is good for beginners who have never used a 3D printer, and it's also good for older guys like me who've been doing it for a while, but want to see, learn, get ideas from my experiences. So if you want to learn more about 3D printing, stay tuned and let's learn something together. Now, if you're watching this video, you know I have a YouTube channel. But MakeWithTech is a lot more than a YouTube channel today. I want to just tell you about two of the other components, properties of MakeWithTech. The first is forum.makewithtech.com. You can go to forum.makewithtech.com and you can leave notes, leave comments, post pictures, ask questions of thousands of people that watch my videos. The second place you should know about is models.makewithtech.com. If you want a better way to search Thingiverse for models, or more importantly, you want to learn about some new highly creative models that are designed to be customized online, right in the models.makewithtech.com website, and then convert it into an STL file so you can print it, then head over to models.makewithtech.com. So let's start with number 1. Yes, that's a picture of a sewing machine. Now, why is there a picture of a sewing machine on a 3D printing video? Well, I'll tell you. It's all about Howard. Everyone has a Howard in their life, or at least everyone who has bought a 3D printer and begun playing around with it. So Howard's my next door neighbor. He's a really smart guy, and he's a lawyer. So he's very analytical. He's also a really nice guy. But when I go starting to talk about the things I'm doing with 3D printers, his eyes start rolling. He says to me, "You're nuts. Why would you buy a 3D printer? You can go online, you can buy all that stuff cheap, inexpensive today. Why do you want to spend all the time and effort to 3D print things you can just buy?" Well, Howard's missing the point. And the point is the same point as a sewing machine. Now, I buy my clothes. But there are millions of people who enjoy designing and sewing their own clothes. So they go and they buy a sewing machine. Some people buy table saws and make their own furniture. Why do they do that? Well, there are 2 reasons. The first reason is, and this applies to 3D printers, it allows you to make bespoke items. Bespoke items are items that are custom, that are unique, that are exactly what you need. So let's say you have a stroller for your kid, or in my case, for my grandchildren. And one of the wheels on that stroller breaks. And maybe it's not a new stroller. It's a 10-year-old stroller that my other children used for their kids. And we're having trouble finding one of these. Well, I have a 3D printer. So I can just print a new wheel. And this wheel we're going to talk about because it's printed in nylon a little later. The second reason is people make things because it feels good. So when people ask me nowadays about 3D printing, I tell them it's just like a sewing machine. Now, item number 2. For those of you who've already used a 3D printer, you recognize this as one of the wheels that you turn under the print surface of your 3D printer. It's very important because a 3D printer prints by heating a filament and using a nozzle to draw patterns on a print surface, then moving the nozzle up and drawing patterns again. The distance between the nozzle and the print surface has to be uniform. So if the print surface is on an angle, it's going to be farther here and closer here. That's not going to work. So you need to level the print surface. And you have some knobs underneath your printer print surface used to level it. Many of the newer printers, though, have a system called auto bed leveling. And let me tell you a secret. That's great. I love it, but it's not perfect. So if you have a 3D printer, this is hint number 2. And it has auto bed leveling, but it also has knobs under the print bed. Before you use auto bed leveling the first time, manually level that print surface. And all the things I'm going to tell you about, like leveling a print surface, you can search for on my channel, or there are many other creators on YouTube who also speak about them. So look up some videos about leveling the print surface, even if you have an auto bed leveling system, and level the print surface before your first print. Hint number 3. When I started with 3D printing, there really was one choice for consumer grade 3D printers, and those were FDM printers. FDM printers use a plastic filament. The plastic filament is heated in a nozzle, extruded onto a print surface. They work basically like a glue gun. But over the last couple years, you see a lot of resin-based 3D printers. And a resin-based 3D printer uses a completely different process. So let's compare those two processes for a minute, and then I'll tell you why I recommend everyone start with FDM printers unless they have a very special need. In an FDM printer, you have your reel of filament. You can see that on the right of this picture. You have an extruder with gears that pulls that filament off the reel and forces it through a tube called a Bowden tube, in many cases, but not all, into the hot end assembly. There's a metal pipe in the hot end assembly that goes into the green area shown on this slide, where there's a heater and a thermistor, basically a thermometer. And the filament goes into that heated section. It's melted and extruded from the nozzle. So the concept's very simple. You pull a filament off a reel, you send it over a tube, you push it into an area where it melts, and you draw lines, then you move up and you draw more lines, sort of like building a house out of bricks. Now, FDM printers are wonderful. They're readily available. There are many, many models at every price point from basically $100. I wouldn't buy a $100 printer, but starting about $200, you get good quality consumer printers up until thousands of printers. If you use PLA, a specific type of filament, they're really pretty safe. This is a non-toxic material. It's made from organic materials like corn. And yes, people will argue that colored PLA, this is actually colored because it's white, it's not the natural color, may have additives that are not as safe as the raw PLA, but in general, it's consumed a very safe material. Let's look at another type of printer. This is called an MSLA printer, a masked stereolithography printer. The concept is completely different. The concept is you have a vat of resin. That resin is nasty stuff. You don't want to breathe it. You don't want to get it on your hands because it'll harm your skin. So you have to be careful with it. Wear a mask, you wear gloves. Now, what you want to do is you want to use a light source to selectively harden that resin, because when it's exposed to ultraviolet light, it hardens. How do you do that? Well, you have a light source under the mat. You'll see that on the screen here. On top of it, you have an LCD screen, like the screen in a phone. And that LCD screen has the ability to make a dot, a pixel, black or white. Or it could do various shades, but for this purpose, let's say black or white. If that screen on top of the light source has a black dot, no light gets through. If it has a white dot, light gets through. So if you light source, you have a screen. Then on top of the screen, you have a clear vat, at least it's clear on the bottom, that's filled with this resin. You'll see in this picture that you lower a print plate down into the liquid, so it's just layer height, let's say 0.2 millimeters above the LCD screen. On the LCD screen, you turn the dots to white and black, or clear and black as appropriate. Then you turn the light on. Depending on the resin, you might turn the light on for a couple seconds, or 10 or 15 or 20 seconds. When you turn the light off, a whole layer has been printed all at once. This is much faster than an FDM printer. Now, why wouldn't you always use these printers? Well, for one thing, the print area tends to be relatively small, at least in inexpensive units, because you need a uniform light source, you need that screen. Those are expensive components. So to keep the cost area, the print area tends to be relatively small. Number two, the resin is nasty. Number three, you still have to level that print bed. And getting that print bed level, depending on the printer, can be quite tricky. So I do not recommend MSLA printers to beginners or in general to hobbyists unless you have a specific need. What would the need be? Well, you want to print very small models with extremely good detail. This is fantastic for it. You want to print molds for jewelry with very fine detail. This does it very well also. And in fact, MSLA and other resin-based printers are used extensively in the dental industry to make things like crowns. So for my money though, for the things that I do around the house, for the replacement parts I make, I stick to FDM printers, and that's what we're going to talk about for the rest of this video. Number 4, all FDM printers are not created the same. You're going to hear about two main categories: FDM printers that are Bowden tube and FDM printers that are direct extruder. They all have the same parts. They all have a roll of filament, reel of filament. They all have an extruder. They all have a hot end. They all have a nozzle. What's the difference between the two? Where the extruder is. The extruder are the gears that pull the filament off the reel and force it into the hot end. If the gears are mounted on the side, let's say, of the printer, and they push the filament through a tube to the hot end, it's called a Bowden tube style printer. That's the picture you see here on the left. If the gears are mounted as part of the hot end, right on the printer, then that is a direct extruder printer. Direct extruder printers, I find, are more precise because the filament moves shorter distances. Some people do believe, however, that Bowden tube printers can be, in fact, more accurate at high speeds because there's less weight moving around. You don't have the motor on the extruder, but the motor sizes on these extruders are getting smaller and smaller. Now, once you get to that hot end assembly, there are also two types, and they have advantages and disadvantages. The typical consumer hot end is a PTFE style hot end. That's where a piece of the Bowden tube that has a Teflon coating is actually inserted into the hot end all the way down to the nozzle. Because the tube all the way down to the nozzle is this very smooth Teflon-like material, they tend to be very reliable. They're easy to use. But Teflon cannot be heated above about 230, 240 degrees Celsius without giving off fumes that are not good for you. So most consumer grade printers are limited to about 230 degrees Celsius. And we look at filament in a minute, we'll see that will limit your choices a bit. On the right-hand side in this picture, you'll see an all metal hot end. In that case, there's a metal tube going inside the heated area. Those metal tubes can be made of a variety of different materials. They can be a coated metal tube. Most people agree that hot ends that use a metal tube all the way down are a little more susceptible to jamming. I haven't had a lot of problem with them, and I use metal hot ends in a number of my printers. But for a consumer, probably a PTFE style printer with a limitation of about 230 degrees Celsius is a good place to start. Suggestion hint number 5. Learn about filament. So there's a whole video on this channel. There are many videos on YouTube about different filaments. But let me talk to you about the things you need to understand about filament. The filament is made of a material. They often have a short acronym. In this case, it's PLA. That generally stands for a very long chemical name that I can never remember. They have a recommended print temperature, and you'll see it printed in most cases right on the filament. So this is Hatchbox PLA. It says extrusion temperature of 180C to 210C. I like to generally set my printer for the middle of that range. So because PLA generally is extruded at under 220, 230 degrees C, it's the go-to filament for most consumers. But then they also have what's called a glass transition temperature. What is that? Well, when you take a plastic material, or in general you take any material, and you start heating it up, it goes through various states. It's solid, then it goes to a state where it's like putty. That's the glass transition temperature state. It's starting to get pliable and soft. Then it goes to a state where it actually melts. That's closer to the extruder temperature. The glass transition state of PLA is only 55 degrees to 65 degrees Celsius. That means about 130, 140 degrees Fahrenheit. So let's say you print something out of PLA, maybe a bracket for your phone in your car. It's a really hot day in Phoenix, Arizona. You leave the phone in your car, which is probably not a good thing to do anyways, but it's on the bracket, or you just leave the bracket in the car. The car starts getting really hot, that bracket's going to start bending. So you need to know the use of the particular material. I'm probably not going to make coasters out of PLA for hot coffee cups. On the other hand, PLA is very, very easy to print with. It's really relatively strong, but it's brittle. PLA has the characteristic that it's very strong, but then when it breaks, it snaps. It's not very flexible. So these are characteristics you need to know about the different filaments. In general, going down the list, a filament that was used a lot that you see in commercial products like Legos is ABS. ABS gives off fumes. There are a lot of difficulties in printing it. I wouldn't recommend it for consumer and small business use unless you have a special use. PETG prints at a little higher temperature. I think it's a very good alternative to PLA. And the problem with PETG is it tends to stick to the print bed, the surface you're printing on, too well. So you're going to need to use a special compound called a bed adhesive in order to make sure it releases. Or a simpler way is just put blue painter's tape on your print bed. If you're printing with PETG, print on that. If it tears when it comes off, who cares? This stuff is cheap. You can buy it at any hardware store. So for things where you need a slightly higher glass transition point, PETG is great. It's not necessarily, depending on the PETG, stronger than PLA, but it is a bit more flexible. Whereas PLA will snap, PETG will bend more as you stress it. And the glass transition temperature is about 80 C or 176 Fahrenheit. Now, what about TPU? Well, a lot of the phone cases you buy commercially are made of TPU. It's a flexible material. It is very difficult to print on most Bowden-style printers. Why? Because it's like a wet noodle. So trying to push it through that tube reliably is hard because it's like a wet noodle. But a direct extruder, where the extruder is right on top of the hot end and it's just pulling it and pushing it a short distance, those work great for TPU. So I've printed a lot of things out of TPU. And then there's nylon. Now, I think nylon gets a bad reputation. It gets a reputation of being very hard to print. I don't think it's hard to print at all if you use the right nylon, because there is actually nylon that will print at about 230 degrees Celsius. Often nylon requires 260, but 230 is really very doable in most printers, and this was printed at 230 degrees Celsius, and it's a fantastic print. What's the other challenge of nylon? Well, the other challenge is you got to keep it really dry. It's hydroscopic. That means it absorbs moisture, so you got to store it in the right bag. And unfortunately, if you're going to print with nylon, you probably need to buy a filament dryer. Now, these are not all that expensive anymore, well under $100 depending on what you're buying. And they will dry out your filament before you use it to print. Number 6, slicers are not scary. Say that together with me. Slicers are not scary. Now, what is a slicer? Well, somebody designs a three-dimensional object. They design it in a computer-aided design program. They design it with a script out of OpenSCAD. They customize it on models.MakeWithTech.com. And you have a three-dimensional object in a file. It's in a format a 3D printer can't print. A 3D printer is really a two-dimensional device in many ways. It prints a flat layer. Then it does move up and print another flat layer, and move up and print another flat layer. But it needs to know about how to draw that flat layer. It's sort of like a plotter with a pen. It needs to draw that flat layer. So there's a program that takes that three-dimensional object and slices it into individual slices, individual flat layers. That's called a slicer. The one that comes with many consumer printers is called Cura. And if your printer comes with Cura, I would stick with Cura. I've used a bunch of different slicers. I like the PrusaSlicer for multicolor prints. I like IdeaMaker for multicolor prints with specialized two-color printers called IDEX printers, but I really stick with Cura most of the time. Now, what format is the slice file in? It's in G-code. So this is what G-code looks like. This is not scary either. It's just an instruction to the printer for where to go and how to draw a line. G1 says go to X10, Y10, X, Y, Z0, that means on the first layer, and then extrude at 3,000 millimeters per minute, 0.04 millimeters of filament. Simple. That's what a slicer does. Now, what people get scared about is they go into a slicer like Cura. They ordered some printer that nobody's ever heard of. They go in to Cura and they go to add their printer. It's not listed. What do? Oh my gosh, it's not going to print. Nonsense. There are really only a few general styles of FDM 3D printers. There are 3D printers that look like a Creality Ender 3 or an ANET 3D printer, or they look like a Prusa. They have the same general shape and form. They have a print bed that moves back and forth or potentially up and down. They have an x-axis, a y-axis. They have a couple rods to move the print gantry up and down. If you have a printer that looks like an Ender 3, select Ender 3 from Cura as your printer. Yeah, I know you don't have an Ender 3. Select Ender 3 anyways. And then, when the printer name is displayed, you can click on the printer name. You can click on Manage Printer and Machine Settings. And on the left-hand side of this screen, you'll see the only thing you really need to change in order to get started is if the size of your printer is different, X, Y, and height, put in the correct size for your printer. Then click on the Extruder tab, and if you're buying a consumer printer, 90% of the time it's going to use a 1.75 millimeter filament, and you're ready to print. Now what about profiles? That's setting up the printer. What about profiles? Any of the standard Cura profiles are pretty good today. So even if you're not using an Ender 3, if you selected Ender 3, select the normal Ender 3 profile and try a print. And if you've leveled your print bed, that's the first thing you always do when you get a 3D printer. In all likelihood, it's gonna work fine. Number 7, I personally don't like fully enclosed 3D printers. This happens to be an Ultimate 2 from Monoprice. It's a great printer. I used it for about 2.5 years. I just donated it to a school. It'll last another 2.5 years. Why don't I like fully enclosed printers? Well, theoretically, they give you the ability to use more filament types that require better controlled temperatures. Nylon likes better controlled temperatures. ABS likes better controlled temperatures. If you're using it at a school or library, they keep little fingers out of it. Here's the problem. PLA, which is what most people print with, doesn't like tightly controlled temperature. It likes a lot of airflow in order to print reliably. And therefore, if you're using a fully enclosed printer with PLA, you're probably going to end up leaving the doors open anyways, unless it has a built-in fan, and most of the low-end ones don't. The second thing is, the last hint we're going to talk about is about printer maintenance. It's really hard to fix and maintain things on fully enclosed printers. You can't get to all the stuff. It's just really hard to get to the stuff. So I don't like fully enclosed printer. What I do like to do is to buy an aftermarket enclosure if I want to enclose my printer. You can buy them from anywhere from $50 to $500. They're available on lots of aftermarket sources on the internet. So that's a case around the outside that you basically put over your printer, and you can take it off any time if you want to work on it for maintenance. Number 8, bed adhesives are not cheating. Yeah, I know. People have told you you can use hairspray. Well, that's messy and ugly. You can use Elmer's glue. You can use this, you can use that. Well, nowadays they make things that make it easier to ensure your print sticks to the print bed. Use them. They're not expensive per print, a few pennies per print. Now, a tube of this is $15, maybe it's $20 now, but in the scheme of things, if you save a whole bunch of prints because your prints come loose because they're not sticking to the print bed, because that first line you draw on the print bed has to stick, and when the print bed cools off, you want it to come off, print adhesives make a big difference. If you're using PETG, you must use a print adhesive of some type so it will release, or some type of material depending on your print bed, or it will damage your print bed. Item number 9. There are a variety of components in every 3D printer. There's the heating element in the hot end. There's the thermistor, effectively the thermometer on the hot end. There are a series of different stepper motors. Those are motors that precisely turn just the right amount that are used on various components. Specifically, there are 2 areas of every 3D printer that are relatively easy to calibrate, where calibration is where you match the software to the characteristics, to the performance of the components in your 3D printer. You can't change the components in the printer, but you can match the software to those components. The first calibration you want to do on every 3D printer is called PID calibration. When you want to set the temperature of the hot end to a particular temperature, you basically turn the heating element on till it gets to the right temperature, then you stop. But it's not that easy. Try to heat up a pot on the stove and keep it at exactly the right temperature. What you actually do is you heat it up till it goes slightly above the temperature you want. Then you turn off the heating element, it cools off a little bit. Then you turn on the heating element and you're turning it on and off. The rate at which it heats up and it cools down is all captured in the PID parameters. And there's a procedure you use for setting PID. That procedure consists of connecting a USB cable to your 3D printer and to a computer, and then running a G-code terminal application that allows you to send commands to the printer to calibrate the PID parameters. Likewise, every stepper motor, those motors that turn your extruder specifically in this case, are a little different. But you want to make sure when you tell the extruder to extrude 100 millimeters of filament, it extrudes 100 millimeters of filament. It pulls 100 millimeters off. So how do you do that? Well, once again, you can't change the stepper motor, but you can measure what it actually does and then put those parameters into the software in your 3D printer. That is the E-step stepper motor calibration. Now, there are a variety of software programs you can use to connect your computer over a USB cable to your 3D printer, but many of them are old. They don't all work quite the way you'd like. They may not be supported on the latest version of Mac OS or Windows. So I created a custom utility just for this purpose. It's called 3D-printing-tools.makewithtech.com. If you go to that URL, that web page will walk you through calibrating your printer, and it supports connecting your printer over a USB cable. Number 10. Printers are mechanical devices. There are lots of moving parts. They get loose. So on a regular basis, that might mean weekly if you do a lot of printing, it might mean monthly if you print periodically, you need to go through your printer and tighten up all the bolts so that they're snug. You don't want to over tighten things. So they're snug. You need to tension all the belts so they're snug. And one of the most common calibrations on a lot of printers today is you need to calibrate how the print head rides across the x-axis. So the print head is sitting on the x-axis. There are different ways that it sits on the x-axis depending on the brand of printer you have. On a lot of printers, they use wheels to hold that on the axis. And if those wheels are too tight, it's going to rub. Same thing for the print bed on the bottom. It's going to rub and not move smoothly. If they're too loose, you're going to get wiggles. It's not going to be great. And your print quality will suffer. How do you tighten those? They use something called an eccentric nut. So you'll see on the left-hand picture that above one of the wheels is something that looks like a large nut. The other wheel is just a round post. If we look on the right side, we'll see what that nut actually looks like. The center of the nut is off-centered. So when you turn it, it moves that post in and out. So you can tighten that up and loosen that up. If you see these eccentric nuts on your 3D printer, about monthly, you need to make sure they're properly tightened. So if you check your belts, your bolts, you re-level the print surface manually about once a month to make sure it's right. You make sure cables are plugged in all the way. And I like to use silicone grease. And you can buy it from a bunch of different manufacturers to lubricate the rods that the Z-axis uses. Those are the rods that the X-axis moves up and down on. Well, folks, I hope you learned something today out of these 10 hints and some other comments I've made along the way. There's probably something in this video for everyone. If you did, give me a thumbs up, subscribe to the channel, recommend these videos to everyone you know. Go to models.makewithtech.com to find models. Go to forum.makewithtech.com to discuss this video. And most importantly, let's continue to learn things together.